Hello friends, welcome to Joy of Life. So we are at the fourth episode of System Design Fundamentals, and before that we are going to take a quick look at the questions that we have received. So there is just one question from John and pretty long questions. So before we discuss this question, I would like to request you all that if you have any doubt, please feel free to ask the question. We are going to make it an interactive session. So if you have any doubts, please let me know in the comment section. We are going to discuss about it in a lot more details. So coming back to John's question, could you please give us a brief about ALB and NLB and also when to choose one over the other? In general, I think we should be preferring stateless load balancer. For instance, assume we have two load balancer in place. Let us say that we cache some data in LB1 or store some data related to number of connection from client for rate limiting. Something else in LB1, assume that LB1 goes down, so we lost the entire data stored in LB1, correct? Yeah, it is correct. So in which scenario you recommend stateless and stateful load balance? So it completely depends, John, and if you see that what we did over here is that we kept the cache separate from the load balancer, right? So we'll be storing here, even if the load balancer goes down, a new load balancer that comes into place will have the access to the cache. So we are not going to store the data inside the load balancer so that it can take it to its grave, right? So we are going to keep it separate. We are going to discuss more in this episode that how we are going to prevent such scenarios. Can you please give us a brief difference about load balancer and API gateway? Yeah, that's the topic of this video. API gateway is what we are going to talk about. We have talked about a lot of features about load balancer. So this was more of a gateway for us, and there are a lot of functionalities that we talked about, right? So we are going to take a deeper look to understand what it offers, a typical load balancer offers, and how it differs from API gateway. Even API gateway can do certain things that a load balancer can do, but we are going to take a deeper look into the same. If possible, please try to create a load balancer in cloud platform like AWS and walk us through the parameters while doing so. Definitely, we are going to do that as well, John. So let's start with the first question, difference between ALB and NLB. So the application load balancer works in layer 7. So we call it a layer 7 load balancer, right? So this is the layer 7 application layer. And we call NLB the layer 4 load balancer. So this is layer 4, 1, 2, 3, and 4 transport layer, right? So this is a big difference, right? So a layer 4 load balancer simply forwards your request of the packet to the upstream servers without inspecting the content of the packet. So it doesn't know about the content of the package. In this case, they can make limited routing decisions since they don't have the content with them. So the options are lesser in this case. Whereas the network 7 load balancer, this one over here, it terminates the network traffic. Since this is the last layer, the network traffic is terminated and read what is the content of the message. So once we can read the content of the message, we have more control over it. So as you mentioned, we are going to take a look at AWS. So here we are at the AWS console, and we are going to take a look at the load balancer first. So here we are, you can see that load balancer, it's a EC2 feature. So let's go ahead and check the load balancer. So currently there is nothing created. You can choose the region where you wanted to create. So we are at Mumbai, as you see on the top right section, and we are going to create a load balancer. So here you can see that there are two types of load balancer, application load balancer, network load balancer. We are not going to talk about the gateway load balancers. So this is the layer 7 load balancer over here, and this is the layer 4. So let's go ahead and create a load balancer over here. So once we choose create over here, you need a load balancer name. So let's say I wanted to load balance my books. So I'll call it books LB, and so let's keep it internet facing, and you can also choose to make it an internal one. For now, let's keep it internet facing, and the IP address type is IPv4. Over here, you need to choose the VPC. We are going with the default VPC. And here are the region mapping. So network mapping, the load balancer route traffic to target in the selected subnet and in accordance with your IP address settings. So I want my load balancer to send the traffic to these two regions. Security group, we are going with the same security group, and we are doing it for HTTP port 80. So this is the listeners and routing config. And what it will do is it will route the traffic to a target group. I don't have a target group over here. So let's go ahead and create target group. So here is the wizard for creating the target group, and target type is instance. You can choose IP address, lambda function, or application load balancer. So you can route your traffic to another load balancer as well, as we have discussed, right? So you can have all these configs. So let's stick to instances for now. So target group, let's say I am creating it for the books module or the book services, and you can choose the HTTP protocol version, HTTP 1, 2, gRPC. And as we have discussed, if you remember, we need to give a health endpoint so that it can goes ahead and check that it's healthy or not, right? If you remember, we have discussed it in the last video over here. Here are some of the advanced settings that you can check. So we have the healthy threshold, unhealthy threshold, timeout, and interval that you can configure over here. So unhealthy means the number of consecutive health check failure required before considering a target unhealthy. So if the target fails to respond to the health check consecutive 2 times, I'll consider it as unhealthy. Similarly, we have a healthy. So once an instance is back, the number of consecutive health check success required before considering unhealthy targets healthy. So if an instance go down with 2 unhealthy health checks, then I would need 5 healthy calls, consecutive healthy calls, in order to call it healthy again. So this is more of a recovery setting for an instance. Then you have the timeout in seconds. So you can just give a timeout, how long it should wait to get the health check done. The amount of time in seconds during which no response means failed health check. So this health check should respond me within 5 seconds or the configured number of seconds over here. And the approximate amount of time between health checks. So the health check is something that will continuously happen between the load balancer and the service. So it is configured as 30. So every 30 seconds it will go ahead and call the health check endpoint, and it should return a success that is 200. If you have something else, generally it's 200, you can just configure it over here. So that's for the advanced health check setting. So let's go ahead to the next. So over here you can see that we don't have any instances over here as of now. So we are creating a new instance. So your instance, EC2 instance, will all be visible over here once you have them. So let's go ahead and create this target group. So you can see that your target group is created and we don't have any instance. So if you are spinning up new instance of EC2, you can just put it inside this target group. So let's go back to the load balancer settings over here, and let's refresh, and our target group should appear over here, and we can see that we have our books over here. So similarly, you can add more listeners. So you can add another listener over here. You can just go ahead and specify that if the request is coming to port 81, what you should be doing. So let's not do that, and let's go ahead. So one interesting thing to observe over here is that you can have a static IP address. So create an accelerator to get a static IP address and improve the performance and availability of your application. So it will come with additional charges, but if I do so, I'll have a static IP address, and which can be used for my DNS lookup. So for my DNS, we'll go into that. We can directly have a static IP address over here. So let's uncheck it for the time being, and that's how you create your load balancer. So you must be thinking that we have discussed so many things. Where are these options, right? So that's something interesting. So we have something called the API gateway to handle all these things. The load balancer and the API gateway does have a lot of things in common, like it can distribute, it can do all those things. But if you take a closer look at the API gateway is used to control your APIs, which are connected to your services, right? Or your microservices, right? So if I take a look at this list over here, you will see this rate limiting, your compression, your authentication, your request handling, all these things, your caching, all these things are specific to your service, right? So the load balancer is intended to distribute the load. That's the main thing it should focus on, right? Apart from that, we have seen the health check. You can definitely have a scaling, you can have a firewall, and you can have the monitoring and logging in place. So let's go ahead and create this load balancer, and let's see what are the options that we have inside this load balancer. So over here you can see that it's in a provisioning mode. So let it complete. In the meantime, we'll take a look at the network load balancer. So we said that it's a layer 4 and it cannot make as much decision as it can make in the layer 7, right? So if you take a look over here, so most of the settings are same over here. But if you see over here, you don't have this HTTP, you have TCP, you have TLS, you have TCP UDP, you have UDP, right? So you cannot make out what is in the packet at this point. So you have these protocol that is available to you. So that is going to be a big difference between the two. But if you have focused over here, you would have noticed that you have HTTP and HTTPS as well. Now the packet is unpacked and you can have more granular control working with a layer 7 load balancer, which is this one. And for the layer 4 you don't have so much of control as we had in the layer 7. So this is layer 4, right? So that gives you quite a lot of difference between the two, which is a very big difference, right? So it is still in provisioning state. I cannot go inside the same, so let's wait for it. In the meantime, let's go ahead and try to understand how the API gateway differs. So coming back to the drawing board over here, so what happens is my load balancer is capable of having some static IP address that we have seen. So I will have one or more instances of the load balancer, so LB1, LB2, LB3, and I will have my API gateway, API gate 1 and let's say API gate 2, right? So what will happen is, so this load balancers will route the traffic to the API gateway, and this API gateway will be responsible for sending it to the right set of services. So we saw the target group, right? So this is my books target group, right? Let's say, and we have my search target group. And we have multiple instances of books running inside it, right? So we'll have something like this. So we will check on the API gateway what kind of request is this, and we are going to distribute it over here, right? So one of the instance among these instances is going to cater to the request that came in. Same goes for this guy as well. So it will have something like this, right? So this is also, this API gateway is also a managed service who takes care of routing this request to the appropriate microservices, right? So tomorrow, if I have a new service coming up, let's say I have a new service called a notification service that I wanted to bring into my features over here. So I will have a target group and I will just tell the target group to my gateway, right? And there is a mechanism to do so. We are going to talk about it in more details. So you can see over here, the load balancer does not need to know about any of the next to next layer. So if I consider it to be my layer 1, layer 2 and layer 3, so only the API gateway needs to know about this. So there is a cross cutting. So all this load, let's say we have 10K load coming in to the load balancer in these services over here. So it is just going to send the 5K just for example, and then we are going to route it to the appropriate services based on that. And if we need to scale, we are just going to add it to the target group, right? We don't need to care about the load balancer. The load balancer doesn't need to know about it, right? So we can simply have the scaling mechanism in place to get things done. So all these concepts that you have seen with a single tick, like rate limiting, compression, authentication. So I can have my authentication and authorization services running here, which the API gateway will directly access and give me the access as well. And we can have a cache over here, right? We can these guys can talk to the cache to cache their data and get things done. So though both load balancer and API gateway looks the same, but they differ in the way they behave, right? The API gateway is more of a service concept over here, and this is more of an infra concept, I would say, right? So he doesn't need to know, he just need to distribute the load that's coming in towards him, but he is making all the API management related decisions over here, right? If I need to do a monetization on some of my APIs, I can have a service plugged into the gateway which will take care of my monetization. So this is quite a business oriented cases, right? But wherein the load balancer is only responsible for distributing the load throughout the application. So with that, let us go and refactor the design that we have created using diagrams.io, and let's make these things fit inside the same. So before we move, let's take a look at our load balancer, which is active now, which is ready, and you can see the configurations over here. So you can see the name over here and all the settings over here. So it's internet facing application load balancer. The state is active and you have all the details over here. Here are the attributes, and if you want to check on it, the monitoring part, you can have a look at how it's performing and all those things. You can configure CloudWatch to find more details. We have configured only one listener, so it's listed over here. There isn't any integrated services because we didn't integrate. So if you want to integrate with any other services, you can do over here. You must be thinking that where do I get the option to change the algorithm, right? We talked about several algorithms. So let's check on that. That will be present under your target groups. So over here, you can see that we have the books and you can configure the target groups from here. So if you go to the target group, you can see all the settings over here. And if you go to the monitoring, once again, you can check the monitoring and you can also take a look at the health check. So yeah, all the configuration is listed out over here. Now going to the attribute part, you can see that it is set to round robin. You can click on this edit button and change the algorithm. For now, it supports least outstanding request round robin. And if you want stickiness, you can configure it over here. And you can also configure the number of days you want it to be sticky. So it can vary from 1 second to 7 days. You can change it from here. So the advantage with this approach is you can configure different algorithms for your different target groups, right? So if for books, I can have a round robin, but for the search, I can use a totally different algorithm for distributing the load. So with that, let's move to the diagram wherein we are going to update the diagram. So let me remove those lines first. So this part is still fine, but definitely a single load balancer is not good, and I don't recommend that either. So we'll get the cache out of the picture and put another load balancer just for the sake that if it fails, if the first load balancer fails, there should be somebody to rescue me. So let's say these are my two load balancers over here, 10, 18, 45, 36 and 37. So what I'll do is I will have both my load balancer mapped to this, and I will update my load balancer over here. I'll make sure that both my load balancer uses the same memory, right? So that we don't have a problem with that. So with that, what will happen is now we don't have a single point of failure, and definitely this cache is a distributed cache and it's not sitting in just one place. So over here, after the DNS is resolved, so we got the DNS resolved using the DNS lookup, and with that we are redirected to the load balancer, either of them, and then we should have the API gateway. So we have the API gateway in place. We'll have multiple API gateways so that we can eliminate a single point of failure. So let's say these are my 3 API gateway, and what this load balancer do is they send the traffic to the API gateway. They do nothing else. They just simply send not to the service but to my API gateway over here. It looks something like this. This load balancer is sending to these gateway, and this load balancer is also sending to these 3 gateways only, right? And if I need to cache some data, once again, I can use a cache which is shared by all the 3 gateways. Just in case if the gateway service is down, it does not take the data to its grave. Same like the load balancer, right? But with the load balancer, I can have a static IP address, but with API gateway, I cannot have a static IP address. So when a request comes to the API gateway, the API gateway knows how to handle this data, and it redirects the traffic to the respective API that is required to be called. So let's say this gets called in this case. So this diagram needs a little bit of refactoring because all these clients over here, these clients, they also are in the Asia region, right? So we need to put them back into the Asia region. So let me go ahead and change it first. So at a very high level, it would look something like this. So we have all the services, billing, card, search, and books inside Asia, and we have only books in EU. Since you have a multi-region deployment, something like this, what will happen is we will take the gateways also inside our region boundary so that we don't need to worry about it. So let me get it inside the boundary. So these are the 3 gateways that we have inside the Asia server. and the traffic will be received by the API gateway, because the load balancer knows the API gateway, and the API gateway will redirect the traffic to the different services as required based on some of the logic. So it will happen something like this, as you see in the diagram. This load balancers will send it over here. So over here, when this load balancer receives the traffic for your books, it's going to distribute the load among the servers over here. So we wanted to keep the architecture lighter, right? Because if the load balancer is doing so many things, it is going to cost us time. So what we are going to do is, as we get the load, we are going to transfer the load to the API gateway. So let us take an example over here in order to understand how it all fits in. So let's say I am getting 9K of requests per second. So 9,000 requests is coming per second, right? Firstly, if we have a single load balancer, it will be a point of failure. And 9K requests for one load balancer, I won't recommend. Though it can support, but I won't recommend. It's better to have two load balancers so that we don't have a single point of failure over here. So what will happen is this 9K request, if I have to authenticate them, validate them at this point, right? So what will happen is the load will be blocked over here. So my lookout is, as soon as I get 9K requests per second, I am going to send it to my API gateways, who's going to get say 3K load per API gateway, right? So what will happen is, now the load is pretty less on my API gateway. So if I have to authenticate, I will do the authentication over here and not over here. So the primary work for my load balancer is to distribute the load among the architecture or the infrastructure that my system has, right? If he picks up the job at the gate and it's going to check a lot of things, what will happen? So the queue at the gate will get bigger and bigger, right? So what I am going to do is, my load balancer's responsibility is primarily to distribute the load. So I am going to do it based on my least connection or whatever algorithm I choose. And I will let my API gateway, since it is very microservice specific, my authorization or authentication of the token or whatever I am getting, I will push those work over here. So this guy will take care of that, and he will redirect the traffic to one of these services, right? So this load balancer, you must be thinking, why do I need a load balancer over here? So you have more than one instances over here. Somebody has to take care of it, right? If we are using K8s, then we'll have multiple pods over here, right? So these are nothing but my pods. If I talk about Kubernetes, so this load has to be distributed among my pod, right? So that's what we are doing with this load balancer. We are just doing a round robin over here. And what I am doing over here is, maybe I am doing a least connection over here or response time, whatever it is. And I am distributing the load among these guys, right? And see the simplicity of the design, right? If I have to add more instances, let's say that I need another instance in my search. So what I'll do is, I will have another instance pinned up just like that, right? I don't need to worry about how my load balancer is going to know about it. So I will have a new instance pinned up over here, and I am going to say this is 41. I don't know, I'm using the same address again all over or not. But anyways, the main intention is just, I will inform this load balancer that I am present over here. So this API gateway and this load balancers do not need to know about it, right? I have just added to my target group. So this is a target group that you can say, right? And if I am having a new service that's being created, right? Just as we mentioned that we might have a notification service. So let's say when an order is placed, I wanted to send out a notification through email or SMS or whatever. If I have a notification service and I wanted to use a load balancer, let's say I have multiple instances, so I will be spinning this up, and what I'll do is, this service over here will be connected through this load balancer, and I have to go ahead and register myself with the application gateway, right? So how this all happens, so let me not put this line over here. So what will happen, the API gateway will send the request to this load balancer over here, right? So it will be something like this, right? So this call will come over here. So you can see that as we introduce a new service over here, my existing architecture or any part of the architecture is not getting disturbed, right? If I need to have a DB, I will have a completely separate DB. And you can understand that the existing infrastructure or existing service is not getting disturbed by this. Now let's say if this service fails, it does not affect the other part that is correctly working. So if this goes down, the notification will stop working, but the entire system of searching, adding the books, billing, card, everything will still function as usual. There won't be any impact to the system, right? And if I have to add a new instance, just say I wanted to add a more books instance, so I'll just have an instance and have it under the same target group, and the load balancer will start sending the traffic to me once the criteria is met, right? We have seen that there should be 5 consecutive success calls, so within seconds that will be up and running. But now the question is, how does this notification service over here that we have created, how does the API gateway knows about it? How does it knows that it is there, right? So as I mentioned, that API gateway is a managed service, right? So this comes with a package. This does not work just like that. There are multiple services under it. There is something called a service discovery. So this service discovery knows about all these services. So as they spin up, they goes and contact the service discovery. So all of these guys will go ahead and register itself with the service discovery. So this is more like a yellow pages that you can say. So everybody will come here and it will tell that, okay, I am present here. This is my IP address. So there are too many lines. Sorry for it. We can't help it. So every service over here will have the service discovery in place. So the moment it comes up, it goes ahead and register itself with the service discovery over here. And this service discovery, this guy knows that, okay, I have to go ahead and check with these guys that they are healthy or not. If new service is added, they will come and register with me. And this API gateway will call the service discovery in order to know that what are the services and the mappings that's available with him. So this is all under the hood of this API gateway, right? So if you're configuring it yourself, you'll find that you have a lot of discovery services framework as well. I have created a video on the same as well. So once again, back to the project that we have created earlier over here. So you can see that we have used Eureka and Zool in order to create the discovery service and the API gateway. So if you take a look at this video where we have discussed in lot of details how this service discovery works, right? And whenever a service comes up, it shows up over here. So this is the Eureka client. So this Eureka goes ahead and finds out the servers, and you can see a hands-on demo on this episode of mini system design project that we have done of the URL parser. So you'll see that how the services is getting registered over here. You can see that multiple services are registered over here, right? As in when they come up, they go ahead and register itself. So we need to provide a configuration based on which it goes and register itself, and it will go ahead and renews the threshold. As you see over here that you have a renew threshold. We are going to do all this exercise as a part of this series as well, but not right now. We'll start with the basic API in the next episode, and we are going to build it up iteratively. We are going to focus more from the infra side to build it up slowly. So do let me know in case if you have any doubts or question regarding this episode that we have discussed. So once again, just to summarize, the API gateway and the load balancer, though they look a lot similar, but they have a lot of things which are not at all the same. Going back to the AWS console, once again, over here also you can find the API gateway. So you can configure your API gateway. So this is also a service over here. But if you take a look at the load balancer, you will find that it is listed under the feature, right? It's not listed under the services. So API gateway is more of a managed services for managing your API. So let's go ahead and take a look at the API gateway configuration over here. This is the dashboard for creating the API gateway. Let's go ahead and build a HTTP API gateway. Build low latency and cost effective REST APIs with built-in features such as OIDC, OAuth 2, and it works with both HTTP, Lambda, and all those things. So let's go ahead and take a look. So over here you need to give a name. So let's go ahead and give a name that we wanted to build for our search API. So you can add an integration over here. So you'll find all the integration listed over here. We have Lambda and HTTP. So let's say we are choosing HTTP. And since our search is a get endpoint, so we are specifying it as get. So this is our integration that we have just made. And with that, we can create more integration. Let's say I am creating another HTTP one, and I wanted to really scale up my books endpoint, the creation of books. So let me just name it book. So you can see that I have created a get mapping for the search and a post mapping for my book, right? And let's call it my gateway. Let's call it books gateway. And let's go ahead and create this gateway. So this method /search will map to this search path over here, and the /books will map to this one. So you can just go ahead and change this to say post. If you want, you can add more routes. You can just simply click add route and add more mappings to your different API endpoints. Okay, so the default name, we are sticking to the default name, and here we have created these two endpoints. So we can route this traffic now based on the rules that we have set it up over here. So the integration is for get on the search and post on the books, and the route endpoint is /search and /books. And you can just go ahead and create them. But if you look interestingly, there was no option that you can create a static IP address over here. You can have your routes configured, you can have your authorization enabled for them, you can have integration with different endpoints, you can have a course. So if you wanted to check on the headers and things like that, you can have export different stages, you can have the throttling configured over here, you can have your matrix, you can have your logging. But nowhere in the system we have seen that we can configure a static IP address for the same. It is not supported as of now, but definitely I am not very sure about the load balancer option, the third load balancer option that we have seen over here. So probably that is a mixture of both, and it can have both the features, but I'm not very sure about that. I will explore about the same and get back to you guys, but I haven't used this one ever. And we have a classic load balancer. This is previous generation, so it's again a layer 7 as well as a layer 4 load balancer that you can create over here. But let's not go into that. It's not relevant for the moment. So let's go back. Though the API gateway might look that it can do the same thing as a load balancer, but it is not meant to be the same. It is meant to manage your APIs rather than doing a load balancing. So in our design over here, we have given the task of load balancing to the load balancer, and sending the API to its rightful destination is left with the API gateways over here, which should ideally happen like this. So with that, we'll end this episode over here. Do let me know in case if you have any questions. We are not done yet. Definitely we are not done with any of this concept that we have talked so far. We are going to do hands-on with all of them. But definitely do let me know in the comment section. I would like to hear from you guys that it was helpful or not. Even if you don't have a question, do leave a comment in the comment section below and let me know how's it going so far. And if you have any doubts, please feel free to mention it on the comment section. So thanks once again for watching the video, and see you soon again. Bye bye and take care.